Hello everyone and welcome to this section. In this section, we're going to cover the basics or fundamentals of computer vision, and we're going to understand how can we represent an image, how to obtain the features within the image, how to obtain, for example, the gradients of an image. It's very exciting, and I'm very excited to discuss all these fascinating topics with you. The first step is kind of an introduction, which is what is computer vision? The computer vision is kind of a science that's used to make computers understand what's happening within the image, okay? If there's, for example, objects within an image. In case of self-driving cars, if there is like a pedestrian that has been detected, if there is a specific lane that I need to be centered within, if there is a traffic sign, for example, that I would able to see, and so on and so forth, okay? So again, computer vision is a science that allows computers to understand images and videos and determine what the computer sees or recognizes. That's pretty much it in a nutshell. All right. So let's take a look at how humans actually use their eyes per se, or the video stream that we acquire through our eyes all the time, and we can see how can we imitate it in a computerized fashion. All right. So that's how humans in general see. So let's assume that we have our, kind of image like this of like a horses, for example, in a farm with like a bunch of mountains. The sensors that we use obviously is our eyes, and then all the data can be sent to our interpreter or our brain, okay, in our vortex. They can specify, okay, what can we actually see, and classifies, for example, what we can see in the image and tell us, its guesses, okay. So, it might guess, okay, we are seeing a horse, or maybe horses, group of horses together, or maybe a mountain, and maybe a farm, maybe all of them together, and so on. All right, and that's how humans in general perceive or understand or sees or recognizes objects within an image. How can we do that in computerized form? It's actually the same thing. So if we use the exact same image, we're going to use a camera, okay, camera to take just one standstill photo or kind of a video or a stream of photos. And within the computer, what we're going to do is I'm going to, develop algorithms to tell us or classifies, the images to, again, horses, mountains, farms, and so on and so forth. Okay, that's pretty much what we're going to do throughout the entire section. All right. So why is it important? Why computer vision is important? Actually, computer vision is applicable everywhere, not just in self-driving cars, but it's actually pretty much everywhere. So it can be used again for self-driving cars, for pedestrians and car detection. It can be used for face recognition. All the Facebook, for example, and Snapchat and all this stuff actually has to use kind of computer vision techniques. Object detection, obviously, which is kind of tied to our self-driving cars. We can be used for pedestrian, for example, detection. As you guys can see here, we can detect, okay, this is a pedestrian crossing, this kind of a cyclist, crossing, and so on. We can use it for handwriting recognition. We can use it for license plate number detection. And it's actually one of the very famous algorithms to just read, whatever, take an image of a license plate and can read, the numbers automatically. So it simply, divides kind of, the plate of different numbers or different characters, and use a machine learning algorithm that can tell us, okay, this is a letter A, this is letter N, this is R, and so on. And obviously Snapchat filters. So again, computer vision is everywhere around us. All right. Next question, or the most important question, is why is it so challenging? All right. So I just went on Google and just write, okay, cars. Let's take a look at cars. So as you guys can see, this is basically a bunch of cars. This is images of cars. Okay. We as humans, we can easily classify, these images because we have an amazing, outstanding generalization capability. We can just say, okay, even if we see a car from behind, from front, with different colors, even if we look at, a cartoon, for example, or even if it's very tiny or very small, I can just tell, that it's a car, okay? However, it's actually very complex task to train a computer to actually do it, or train an algorithm to actually do it. Because we need, if you're going to specify, based on colors, actually we have so many different colors. If we specify, for example, different lighting, here you might see a little bit darker image, for example. Or maybe this is kind of a smaller image. There's different scales. There's different orientation of the car. There's car from the front, from behind, and so on. So that's why it's very difficult. It's actually a challenging task to train a computer in the same way that we actually do as humans, all right? I'm gonna go through all these challenges. I'm gonna show you how can we do all these, image manipulations moving forward. All right, okay, great. So let's take a look at a couple of the challenges, and dig a little bit deeper. So the first step is viewpoints, all right? So this is kind of an image of the CN Tower in Toronto, all right? And this kind of a view, like from a kind of a far away, that's kind of a CN Tower, okay? We can recognize it easily. However, viewpoint, if we, let's say, go underneath the CN Tower and look up, that's the image we're gonna be getting. Or maybe if we get a little bit closer and get like, kind of more kind of angle, come up with this, right? However, these three elements are actually the same object. However, it's very difficult, to take all these images and let, a computer generalize, and become way smart from different viewpoints. Can tell, okay, these are the CN towers, okay? We as humans, it's very easy for us to do. However, for computers, it's a little bit challenging. I'm gonna show you how these challenges as we move forward through the course. All right, that's the first step, which is viewpoint. The next step is what we call it camera limitations, all right? Obviously, so, the better camera we get, if we get, let's say, 1080, for example, pixel camera, we're going to be better than 240, for example. Here you'll find that the image is a little bit blurred, or a little bit not like, like the resolution wasn't very accurate or very great. Here, as we increase the resolution, that's better. We get more pixels. So I'm going to show you how can we describe an actual pixel in a digital format. I'm sorry, an actual image in a digital format. And that's, one of the challenges as well as our camera limitations, all right? The next limitation is obviously lighting, all right? Again, here we have our exact same object, which is again the CN Tower. Here in the morning in daylight, maybe the machine learning algorithm or the, computer vision algorithm can tell us, okay, this is a CN Tower, easy. However, at night, if it's a little bit dark, the features for us are the same. However, it's a little bit difficult for the algorithm to actually detect it because, of different lighting conditions, for example. Which is the same again for self-driving cars. We want our car to drive in the morning, at night, everywhere, in snow conditions, everywhere, and actually detect objects and pedestrians and so on. All right? Perfect. The next step is what we call it scaling. All right? So again, here is our object. What if we zoomed in, for example, to take an image like this, for instance, what if we have, for example, classifying pedestrians, we might have a long, like a tall pedestrian, a short one, for example. How can the machine learning algorithm that can specify that, okay, all these are pedestrians, all the cars, for example, a far car, a nearby car, how can we classify all that? That's, the power of advanced kind of, computer vision algorithms, all right? And that's obviously one of the challenges that that are posed to them. The next step, or the last step, is what we call it object variation. Again, I went there, I looked up, let's say we're going to classify chairs, okay? That's, the images of chairs. So all of them for us, even if you show like to it or kind of a baby, he can easily, classify, okay, all these are chairs, okay? Why? Again, because our brain can easily generalize, it has seen like thousands and hundreds of thousands of images. However, to train this, to like a machine learning algorithm or like computer vision, it's actually a challenging task. All right. So again, here we have different object variations. So like the actual chair, this chair, for example, looks completely different than this, looks completely different than this. There's different materials, different textures. That's why it's very difficult to do, or very challenging to do computer vision in general in a computerized fashion. All right, and that's pretty much all what I have for this section. I hope you guys enjoyed it, and I can't wait to discuss future sections with you. Thank you, and see you in the next one.